Welcome back to For the Mariners by the Mariners channel. Inside the heart of every ship, the boiler and its vast water spaces act as a powerhouse that demands constant protection against the silent and relentless threat of corrosion. When high-temperature water meets steel, the resulting chemical reactions can lead to pitting, thinning, and eventually catastrophic failure if not managed with absolute precision. Understanding how we defend these critical systems begins with the science of water chemistry and the implementation of robust protection methods. The primary objective is to maintain an environment where the steel is naturally protected by a thin, stable layer of magnetite known as a passive film. To achieve this, we rely heavily on chemical treatment regimes that carefully balance the water's pH levels. By keeping the boiler water in a slightly alkaline state, typically between a pH of 10 and 11, we significantly reduce the rate of acidic corrosion. This is often achieved through the measured addition of alkaline compounds like sodium hydroxide or sodium phosphates. However, alkalinity alone is not enough because dissolved oxygen is perhaps the most aggressive enemy of marine boilers. Even tiny amounts of oxygen can cause localized pitting that eats through thick steel tubes in a matter of weeks. To combat this, we use a dual approach of mechanical and chemical deaeration. Mechanical deaerators heat the feed water to drive out dissolved gases before they ever enter the boiler, while chemical oxygen scavengers like hydrazine or sodium sulfite react with any remaining traces to neutralize them completely. Another vital layer of defense is the management of scale formation. Scale acts as an insulator, preventing heat transfer and causing the metal underneath to overheat and weaken. We use specialized polymers and conditioners that keep scale-forming minerals in suspension, allowing them to be removed through regular blowdown procedures. In the broader water spaces of the ship, such as ballast tanks or cooling jackets, we often turn to sacrificial anodes, or impressed current cathodic protection systems. Sacrificial anodes made of zinc or aluminum are designed to corrode away instead of the ship's hull or internal tank structure, providing a physical shield through galvanic action. For closed-loop cooling systems, we use corrosion inhibitors like nitrites, which form a protective film over the entire metal surface. Regular testing is the final piece of the puzzle. Marine engineers must perform daily analysis of chloride levels, alkalinity, and phosphate concentrations to ensure the treatment is effective. Every drop of water must be accounted for, and every chemical balance maintained to ensure the longevity of the vessel. If you found this video helpful, please give us a thumbs up, hit the notification bell, comment, like, share, and subscribe for more insights. Thank you.